Graphing cubic functions. And so first we need to talk about what is the parent function. That would be y equals x cubed. And the general form of that is y equals a times x minus h cubed plus k. Just like all of our other, it looks like vertex form, but in this case it's called the inflection point. So if a is positive, the graph goes from bottom left to top right. So it looks something like this. And there is one x-intercept, only one. There's no loop in there. And if a is negative, the graph goes from top left to bottom right. So something like that. And it also has one x-intercept. If a is between 0 and 1, we say it is vertically compressed. And if a is greater than 1, we say it is vertically stretched. Our inflection point is hk, and that goes along with what our vertex was, what our endpoint was for other things. H value identifies the horizontal shift. And the k value identifies the vertical shift. And so remember, with our h value, the x lies to you. The x lies. So when it moves left, it's positive, and right, it's negative. The up and down, though, it stays the same. Up is positive, down is negative, just like all of our other graphs. So let's look at some graphs. We have y equals 1/2 x cubed. We basically want to plug in x values. We want to plug in values. So if you look, when x is 0, y is 0. If x is 1, 1/2 times 1 cubed is just 1/2. And then if we plugged in 2, 1/2 times 2 cubed is 8. So 1/2 times 8 is 4. So the right-hand side looks like that. The left-hand side is a reflection about the axis. So it matches up to the other side. At -1, it would be -1, x -1, y is -1/2. X is -2, y is -4. When we have y equals 2x cubed, when we plug in x, it's still 0. Now, when x is 1, 2 times 1 is 2, because 1 cubed. If x was 2, 2 cubed is 8, 2 times 2 is 16, it'd be somewhere way up. So it grows super fast. When x is -1, -1 cubed is -1, 2 times -1 is -2. So this graph starts to look like it's almost a straight line that has a very high rate of change. We'll keep moving across. Y equals x minus 3 cubed. That means you move right 4. Or right 3, right 4. And so now it just moves our parent function. So the parent function, when you move up 1, it's going to be over 1, down 1, to the left 1, but then when you move to the right 2, it moves up 8. So it goes off the chart on the top and off the chart on the bottom. When you move down 3, like this one is, so I start at 0, -3, when I move to 1, 1 minus 3 is -2. When I plug in 2, 8 minus 3 is 5. So you can see it goes up to that point, and then it quickly goes down. if there is a negative in front of the parentheses, if there's a negative in front of the parentheses, then the graph reflects over the x-axis. So look at that one. That means it's in front of any parentheses. There's none there. If there's a negative just inside of the parentheses, then the graph reflects over the y-axis. And this is kind of the horizontal stretch and compression that we talked about a little bit before. All right, we got a couple more graphs. X plus 3 cubed means left 3. And you'll be able to see how it kind of looks the same. And plus 3 means we moved up 3. So we're 0, 3. It's always going over 1, up 1, down 1. But then when you move to the left or right 2, it really starts to change. So there's our front page. Take a quick look. And now let's flip it over. Okay, so I'm going to draw, it says draw a table with at least 3 points to plot, graph the equation, name the inflection point, and then describe the transformations. I'm going to draw the parent function in yellow just so you can see it. It says 0, 0, 1, 1, 2, 8. And then -1, -1, and -2, -8. So that's the parent function. Now when we look, we can see that 1/3 means we compress by 1/3. And the 5 inside means we shift left 5. So that means our inflection point will be at -5, 0. Right there. So if we make a little table for x and y's, when x is -5, y is 0. Then I'm just going to pick 1 to the right. So when x is -4, 1/3 times 1 cubed is just 1/3. And then I'm going to pick when x is -3. 1/3 times 2 cubed is 8/3. So my points would be here. And then 8/3 is like 2 2/3. So it's going to kind of go like that. And then I'm going to find the same points on the other side. And so I just match them up since it reflects across the axis of symmetry, or it reflects across the point 0, 0. Sorry, I'm drawing a blank right now. Number 2, f of x equals -2 x cubed plus 3. So we would say this one reflects across the x-axis because there's negative. It's stretched by 2. And shifts up 3. So because it shifts up 3, our inflection point is at 0, 3. So we move up 3. And when we draw our little table, x and y, when x is 0, y is 3. When x is 1, -2 times 1 is -2 plus 3 is 1, so it's going to be down here. And then when x is 2, 2 cubed is 8, -2 times 2 cubed is -16 plus 3 would be at -13. So it goes down dramatically. So then we draw our point on the other side, because it's going to grow fast going from left to right down. So if it stretches here, it gets hard to draw because it grows so fast. And then our last one, x minus 5 cubed minus 2 means right 5 and down 2. So when we move right 5 and down 2, our inflection point is at 5, negative 2, right there. And then plugging in x and y, so we know 5, negative 2. And then I'm going to pick 6. 6 minus 5 is 1. 1 cubed is 1. 1 minus 2 is negative 1. So when I move to the right one, I just go up 1. If I move to the left one, I go down 1. And if I move to the right 2 to 7, 7 minus 5 is 2. 2 cubed is 8. 8 minus 2 is 6. So it's going to be pointing at 7, 6. So it's going to look kind of like that. And then I'm going to have a point at 3, negative 10 as well. And so that's what that graph looks like. All right, so now it says number 4, write a cubic function matching the description below. The graph of f of x equals x cubed has been transformed so that its inflection point is 4, negative 1, and it is vertically stretched by a factor of 4. What is the new equation? So we know our a value is 4, so that's what goes out front. We know it shifts to the right 4. So to shift to the right 4, we have to say x minus 4, and then it's cubed. And we move down 1, so we put minus 1 out front, on the back side. Now, number 5 is a little more difficult. Write the cubic function shown in the graph below. So, I don't know why it went there, but we know our inflection point. So let's label that as 0, negative 3. So we know we're going to have, I'm going to put it over here, y. We know we have an x cubed, and we have minus 3, not inside the parentheses. So now we have to figure out what is our a value. So if you look, we can find another point. We have a point at 3, negative 2. And so we have a point at 3, negative 2. We know that a goes out front. So if I plug in these values, I'm going to plug in 3 for x and negative 2 for y. So I'm going to have negative 2 equals a times 3 cubed minus 3. So when I work that all out, I'm going to add 3 to both sides, so that's 1. And then 3 cubed is 27. So I have 1 equals 27a, or a equals 1 over 27. So then my final equation will be y equals 1 over 27 x cubed minus 3. And so that's my equation. Once we know how much it should, we know the transformations up and down and left and right. And so then trying to find the a value, you just have to use a second point along the graph and plug it in and solve for a. So hopefully that helps you out, and that now you feel comfortable and confident graphing cubic functions.